Oh, man, that's annoying. Okay. All right. Okay. We are going on YouTube right now just because the new Blackboard Collaborate thing's not working. Shocking. So went to YouTube. I'll be back. Maybe the Blackboard thing will work again later. So for 3 to 4, we'll try there again. But I'm not going to hold my breath. So I'll be here for office hours. If you have questions, post them in the chat or, send me an email if you can't post in the chat. Okay, remember, send it to the srfox@fcps.edu email. I got to run and get my phone real quick, and so I can monitor the email. All right. Okay, so those of you that are, if anyone's here to ask questions, then again, either post them in the chat or email the questions. If you're here for quiz retakes, email me again, that same email, not the Google email. Email me there which retake you're going to take. And the way that works is I'll send you a copy of the retake and give you the time limit, and you just have to send it back to me within the time limit. I had a question about the key for the Unit 6 practice test problems. The key you sent in the email wasn't the key for that assignment. It was for the Unit 6 mini test. Oh, okay. Let me check to see if I have that key. I think I have that key. Let me just check on that. Okay. So it was the mini test the mini test key that I sent you the answers to, not the practice problems. Okay. Was that the key to the mini test like I assigned before spring break? Is that the one you're talking about? The one that had molarity in it as well? Okay. I think I know what you're talking about. Let me just make sure. What do we got? Let me check. Unit 6, mini test, mini test, mini test. Unit 6. Didn't I just got to find out where I have it saved. Hold on. Unit 6, let's see. Unit 6, test list, test review packet. All right, hold on. Let me see one more thing. What am I doing? Talk to myself here. Where did I put it? Distance learning. No, it's in the distance learning. Unit 6 practice problems. So we need a key to this. Unit 6 practice problems. Okay, so Finley, I'm just making sure. So you're looking for the answer key to this, but I gave you the answer key to that like practice test or something, the mini test. Okay. Okay. Let me see if I have that. If I can't find it, I'll post it later. But if you have any specific questions about a specific one, I can go over it with you currently. If I can't find the key, I thought I had it, but I might be wrong about that. Hold on, I gotta get. It takes a while for the PDFs to open. Okay. All right, I'll look for that. If I can find it, I'll post it. If not, let me know if you have a specific question that I can answer right now, and if not, then I'll post it later. Okay. All right, Eden, I got your email, quiz 2.1. Okay, I'll get that here in a second. Let me just check on this. Come on. Open up. No, that's the wrong thing. Is it? That's stoichiometry. No, that's not going to work. All right, let's see. Thought I had it. Documents. He does practice problems key. Maybe this is it. Okay, I think I found it. I just got to figure out which one it is. Does the one I have posted for you, does it say key one, or maybe it's not the right thing? Let's see. Man. Mini test practice problems. Okay, I found it. So I'll post this one. I think that's it. I think that makes sense. I think that's it. Yeah, okay, I found it. Just ignore the first page of the key, because the first page of the key is molarity practice problems. And if you want to go over those, it's fine. It's just not going to be on that Unit 6 test that you have next Friday. So I'll email that out to everybody real quick, and then and that'll be it. Okay. So, Unit 4 test corrections. Okay. Here we go. So when you look at this key again, don't look at the so wait a minute. I think the one that I have, Finley, let's just double check that. Does it say Unit 6 mini test practice problems key 1? Is that the one that you have? Because if that's the one, yeah, that is, I think that's the correct key. Is that, okay, so, all right. Yeah, it's the correct key. You just have to ignore the first page, the one that I've already given you, I think. You just have to ignore the first page because that has some molarity practice problems that I took off the one that I assigned you. But the key, just because I already had the key done, it it's already on there. So just scroll down. I'm gonna send out the key again, but again, ignore the first page. So I'll send this out, but you just have to ignore the first page. Okay. Let's see. Practice problems. Ignore the first page. All right, there we go. So I'll attach the other one. All right, so that's the one I'm going to attach. But I think the other one that I did post, I think that also had, but I'm probably wrong. Okay. All right, so I just sent that out, so that should be good. I think I did. Did I? I did. Okay. All right, Eden, I'm going to go ahead and send yours out now. Just give me 1 second. Let me go to my email. All over the place today. All right. Try that again, just in case. All right, Eden. All right, Eden, I'm going to go ahead and send you the retake now. It's going to be a 30-minute time window. So like 20 to 25 minutes to take the quiz, and then, make sure you have some time to get it back to me. Okay, so let me do that. Retakes in 2.1. Okay. All right, so again, this will be so in about 30 minutes, so around 12:45, try to get it back to me by then. Okay, so sending your way, just send it out now. Okay. Yumi, I don't know if you're watching, but I just got your Unit 4 test corrections. I'll check those later. Okay. All right. So Finley, if you're still there, I just sent out the key. Although I think it might be the same thing that I attached. I might have I know it's titled differently, but if you scroll down from the first page, if you ignore the first page, the um, the rest of the key should be there. Okay. All right. So Are there any questions? They got two people watching right now. I don't know who they are. And Ian's taking a retake. Again, if you can't post in the chat, just send me an email, and we will, and I'll get to you through there. Okay. Okay. Hold on. I'm gonna just going to transfer where I am at. So bear with me. Bless you. You all right?
Good.
All right. I'm gonna move downstairs. Okay. You keep working. Or you keep playing. All right.
Yeah.
Whoa, careful. All right. All right, guys. Just moving locations. If you have questions, please ask. Okay. Okay. We take 4.2. Yep. I will send that your way. Okay, so send me an email real quick, Ashley, and I'll respond to it. Just send it to srfox@fcps.edu. So I'll respond to it with the quiz, and you'll have a half hour to get it back to me after I send it. Okay. So kind of treat it like we're going to be treating question number one on the AP exam, where you get 25 minutes to do it and then 5 minutes to submit it. Okay. So Ashley, if you get this, so send me an email, Ashley. I will attach the quiz, send it to you, and but send it to my fcps.edu email, and you'll have a half hour to do it once I send it. Okay. It's really annoying. It's not working. All right. Okay, Ashley, so I'm going to be sending it your way now. So by around 12:50, please. So you can either, take a picture of it or scan it or however you want to turn it in, but just send me it back around 12:50. That should be plenty of time. Okay. And send it back to me before then if you finish before then. Okay. Thanks. All right. Are there any other questions? So again, if you can't like questions about practice problems you've been doing, homework, or anything else, if you can't email me, or sorry, if you can't post in the chat, email me, okay, and we'll go from there. I got a couple people retaking. So the Blackboard Collaborate, the new thing that was sent out. It's not working right now, so that's fun. Um, but so I guess that's what we'll do. We'll always, for all of our scheduled things, we'll plan on going to that Blackboard Collaborate session, the one that you just got the link for yesterday, from, and we'll always plan to meet there. And if it's down, if it's not working, then we'll just go to YouTube. Okay. One of the questions, okay, Amy, one of the questions in the Kinetics Guided Notes asks, what would the potential energy diagram look like for a reaction that has three steps? There's also a couple questions about endo, exo potential energy diagrams on the reaction mechanisms practice sheet. Could you go over how to determine endo? Okay, so first let's do endo exo because I'll be able to look those up pretty quickly. Okay, so remember, it's just, is energy lost or is energy overall lost or gained? So let's go potential energy diagrams for endo, endo exo. So okay. So remember, the potential energy diagrams, they just look like this essentially. It's these diagrams here, the hump diagrams, okay? So this is essentially what you need to know. Let's go copy image. Let me blow it up. Let me do new. So it's just these diagrams here. Maybe. So if remember the first plateau, the first, hold on. Okay. So it's just the hump diagrams. Those are the potential energy diagrams for a reaction. That's what they are. I'm just waiting for my Word document to respond. Um, okay, here we go. Okay, so the key difference is between endo and exo is just is energy absorbed or is energy released. So this is always like so. Anytime you're looking at these potential energy diagrams, you need to know all three parts. Okay, so this part right here is this is where the reactants are. This is where the products are. Again, reactants, products over here. Okay, we call this the top of the hill. We call that the activated complex, or you can call it the transition state. Okay, that's the transition state. That's the transition state. Okay, but the key is whether to know it's endothermic or exothermic is just is overall as you go from reactants to products is energy gained. Like here, then that means endothermic energy was absorbed or energy released. Okay, so if the products are lower in energy than the reactants, that's exothermic. If the products are higher in energy than the reactants, that's endothermic. Okay, so if you know delta, like if you're told delta H is positive, then the potential energy diagram would look something like this. If delta H is negative, then the potential energy diagram would look something like this. That's really all it's asking. Now, if you have a three-step mechanism, you're going to have two humps, two transition states. So let's see. Let's see. Let me try. I'm going to try to get away with not having to try to draw this because I'm not good at drawing on the computer. But let's do this. Three-step mm, reaction energy diagram. There you go. That works. Okay. Let's see if they give us a good one. Yeah, okay. So if you had a three-step mechanism, it would look something like this. So if you can see this, it's, reactant, product, but these are like, so here is transition state one, transition state two, but this would be the first step and then the so the first step, the second step. Okay, so if it was that would be a two-step process. Sorry, that's a two-step process. Sorry, this would be a three-step process. One, two, three. Okay, so this would be a three-step process, but it would be exothermic. Does that make sense? That would be three. That would be a potential energy diagram that has three steps. Okay, this would be elementary step one, elementary step two, elementary step three. Here's where you would find the intermediates, right? Your first activation energy, your second activation energy, your third activation energy, and then overall it's exothermic because energy was lost. If you were looking for a three step potential energy diagram that was endothermic, it would look. I mean, let's see. So I mean, this would be fine. It would look like that. Again, I see a lot of two-step ones. Where did I see that? Okay, I see a lot of sorry, I see a lot of three-step exothermic, but if it was three step endothermic, the only difference would be D right here would be higher in energy than A, right? But you would have three humps. If it's two steps, you would have two humps, right? If it's one step, that's when you have one hump. Now, really, what the potential energy diagrams we see normally, the ones I was showing you, remember, it's only so what would end up happening is like this just because they give you a potential energy diagram like this doesn't mean it doesn't have more than one step. It just means this hump is represents the slowest step, which would be the rate determining step. So like you could imagine you could have a small hump here, then a bigger hump here, and then a small one here. So you could have other humps underneath the curve, but then the main thing is, you can only go as fast as your slowest step. And so if you just see a potential energy diagram with one hump here, it doesn't necessarily mean it's a one-step mechanism. It just means they didn't show all the individual transition states. They only showed the transition state that is most important when it comes to the rate, which is the highest one, the one with the highest activation energy. Okay. But that's what they're talking about. Okay. Okay. So, um, hopefully that answers your question. If it doesn't, just email me again. Um, and again, feel free to ask about any other questions as well. An FYI, as you're preparing for, yeah, so, okay, so yeah, each hump would be its own it would be the transition state for that particular step. All right, so again, let me pull up our reaction mechanism notes from the lesson and just look at a generic, where would it be? Where do I have it? That's the wrong folder. Okay. So yeah, each step. So remember, if you for a reaction to occur, right, the reactants have to collide. But for each elementary step of a mechanism to happen, the reactants of that step have to collide. They have to have the right energy, and really, that energy is the energy that's required to break the bonds of whatever bonds have to be broken, that kind of thing. It's really to make the energy required for what would be the jumbled up mess of the two reactant particles when they collide before they get rearranged into a more stable state. Okay. So let me see if and that's what the transition state is. The activated complex of the transition state is the it's all the particles of reactant A and reactant B, whatever number of atoms that might be, depending on what types of molecules they are. When they collide, they're all together. At that instance, they're all together. You have maybe let me see if I can draw it with dot structures a little bit better. This is tough to imagine here. But yes, so each step would have its own transition state. We'll go with that. And then each step would have its own transition state. And the well in between the steps would be where you could find the intermediate that leads to the next step. So let's see. Come on, open up. Let's go. And while we're trying to wait for this to open up, within the question, you would be given information on whether or not it's endothermic or exothermic. So the easiest thing, most of the time they'll give you the delta H value, and you just got to know if delta H is negative, they're telling you it's exothermic. If delta H is positive, they're telling you it's endothermic. Okay. But there's a lot of different ways they could tell you if it's exothermic or endothermic, right? They could tell you that when the reaction occurs, the beaker gets hot, so it's exothermic, or the beaker got cold, so it's endothermic. They could tell you somewhere within the question that that the bond energies of the products are stronger than the reactants. That would mean exothermic. They could tell you the bond energies of the reactants are stronger than the products, and that would be telling you it's endothermic. So, they'd have to mention some way that it's endo or exothermic to know what your sketch would have to look like. Now, that being said, this year they're not going to, like in previous years, they've had you sketch, graphs like that. They're not having you do that, so you're not going to have to sketch a graph or anything, because they're saying everything should be able to be answered typed, like using like a Word document or something. So you should be able to type all your answers if needed. So that means they're not going to have you make graphs. But okay, so yes. So if you have a three-step mechanism, okay. So each hump of the three-step mechanism's potential energy diagram would represent the transition state of that particular step. So the first hump would represent the transition state of the first step. The second hump would be the transition state of the second step, and the third top of the hill would be the transition state for the third step. Okay, so if we go back to this, like if this is my mechanism, this is a three-step mechanism. Now, I don't know if this process is endothermic or exothermic. That's something I would have to be told somehow. But yeah, it's not something you would have to guess at. There's something that's going to tell you if it's endothermic or exothermic. Okay. But so this first step, the transition state would be the jumbled up mess of two B particles before they rearrange into a C and W, right? This transition state would represent the jumbled up mess between A and W particles before they transition into the more stable Z particle. And then this would be step 3, the transition state would represent the jumbled up mess of A and Z before it rearranged into the more stable D particle or whatever. Okay. And so, yeah. Okay. Hopefully that answers your question. Sorry it took me a long time to get to it, or to get around to it. Yeah, so if you were given a potential energy, that's a good question. If you're given, like if you were given the mechanism, let's go back to those images here. Like if, let's say you were given this, like, so this is a two-step mechanism, but if you were given this, you know that Well, it's kind of, so this is more dramatic here. This is a three-step mechanism. I know that step two is the rate determining step. The higher the, so remember, this is how this, the distance from the reactants. And so again, this trough right here would represent the reactants of the second step, right? So this would represent the reactants of the second step. And the distance from that trough to that hill is what we call the activation energy. And the higher the activation energy, the slower the process. Because the higher the activation energy you have, the fewer amount of collisions are going to be able to overcome that activation, right? So, so the whatever the highest hump is, that's going to represent the rate determining step. All right. So that's they could give you a sketch. They could say, here's the mechanism, here is the potential energy diagram, figure out the rate law. Well, them giving you this potential energy diagram is telling you what the rate determining step is. Okay, so if you have a mechanism and you know the rate determining step, you could figure out the rate law, and that could easily be a question on the test. They could say, here's a proposed mechanism, here is the potential energy diagram for the reaction, what's the rate law? And you would say, oh, the second step's the rate determining step, based because it has the highest activation energy, so it's going to be the slowest one, and you would go from there. Okay. So yeah, so this would be this would be the slow step, this would be maybe fast, and then this step would be really fast, right? So and sometimes they actually characterize the mechanism that way. They say fast, really fast, slow or very slow, and really that's in direct relation to the activation energy of that particular step. Okay, good questions. Okay, all right. Any other questions? Good questions, Amy. Thanks for asking those. Um, and and also, Amy, don't think I forgot about the reference sheet. I'm just trying to figure out exactly what I want to put on there and how I want to organize it. Um, okay. All right. So again, I know I got a couple people retaking quizzes right now, and if you have questions, again, put them in the chat or email. Okay. And I apologize that that Blackboard Collaborate thing isn't working. I think this is the third iteration of this that we're trying. So we'll figure it out. Has anyone used that Google Meet in their for their classes? I haven't checked that out. I don't know. So, all right. Good questions. And, for those of you that are, if you're watching this later or you can pass the word. So those of you in second period or eighth period AP or sixth period honors, we're going to try again tomorrow to meet during our normal class time in the collaborate session. But again, if it doesn't work, then we'll go to the YouTube session. But I'm not going to do like an official lesson like I did on Tuesday. What I really want to do is just touch base with everybody and make sure that you're caught up and you've seen the videos and answer questions. So it'd be kind of like an office hours type thing. I might, for AP, I might be doing a little bit intro into integrated rate laws and not wait until next week. But I won't go full on into that. Okay. Any questions? All right, I'm gonna give up on that. All right. Whoops. Uh-oh. Looks like we're buffering here. I don't know what that means. All right, we got another one. Yeah, it looks like YouTube's not working. Okay. All right, Eden, I got your quiz. Thank you. Did you want to do the other one that you were talking about? Of course, this isn't working. No, YouTube is slow. All right. Why are you so slow? Come on, man. Let's go. All right, connection is good, but not great. All right, Eden, I don't know if you're going to hear this, but if you, I know you said you wanted to retake another quiz too. So just let me know if you want to. I'm going to try to, I don't know. I guess I could lower the quality here, right? Let's try that. Let's see if that does anything. I don't know. Oh, I guess that didn't do anything. Great. Come on, guys. Okay. All right, Eden, I don't know if you can hear me on YouTube anymore, but I'll send you the quiz and you should be good to go. Okay. And then again, same thing, 30 minutes for this one. And so I'll be sending that out here shortly once I figure out what I'm doing. All right. Got it ready for you here. Okay, so I just sent it your way. So by like around 1:15 or so, that should be good. Okay, and go for it. Okay, let me close this and do that. All right. So so I'm gonna go ahead and leave now because no one's really asking questions, and I just have kids retaking. But if you have questions, still email me. Uh, Email me, and again, I plan on being. I'll be back from 3 to 4. We're going to try Blackboard Collaborate Ultra first, but if that doesn't work, we will try YouTube again. Okay. So again, sorry for cutting it short, but YouTube's is going a little wonky here. But again, if you have other questions, email me. Oh, let's see, I got an email. I'll try to do that. Okay. All right, Ashley, I got your quiz. Thank you. You're good to go. Um, okay. Um, I don't know if you got that message, but thank you. Again, we'll try the Blackboard Collaborate Ultra, um, but I don't know. But if that doesn't work later today, I'll be back on YouTube and I'll send you out the link. Okay. Let's go ahead and end this thing.